Good afternoon. My name is Jonathan Carswell. I've been teaching for the past 4 years. And for this particular digital lesson that we're going to carry out, or virtual lesson that we're going to carry out, the particular content will be tailored to 12th graders. It'll be for the Earth and Space Science class. It will address Alabama's Department State of Education standard number 6, which we'll be looking at when we get into the lesson. And so that will be the structure and what some of the background that we'll be looking at in this particular lesson. And so from here on, I'm going to begin, and then we'll stop at the 10-minute mark in order to discuss the other requirements that were present inside of the video. All right, good morning, class, or maybe good afternoon or good evening. May depend on given that we have a virtual setting, but I hope everybody is doing well today. I would like you to go ahead and log on. And if you will, go ahead and log on, and I'm going to go ahead and share my screen because we're going to get started today. So over the past couple days, we've been looking at some different aspects in relationship to the origin of the universe. And now we're going to start our next unit. And this next unit deals with the early astronomers, okay? It deals with the early astronomers. Now, the 5 astronomers that we're going to be talking about are Nicholas Copernicus, Galileo Galilei, Isaac Newton, Johannes Kepler, and Albert Einstein. And so those 5 individuals have given us substantial and just truly have helped our understanding of the universe in so many ways and fashions. If you will, as we are logging on, I'm going to go ahead and open up our Padlet for us. And that's what's going to get us started today. As we consider some of the things that we're looking at, each of these individuals has a particular contribution that they were able to provide for our better understanding of the universe here. In this Padlet, you have the question, what is the shape of the Earth? And so for the virtual format, what I would do, I would either put this question and this Padlet link inside of the maybe a Google Classroom. I would email to the students as they are entering in, or I would put it inside of maybe a Zoom chat. So as you open up and start to log on, our question for today to get us started is, what is the shape of the universe? I'm going to give you just a few minutes to answer that question, and then we're going to be discussing some of the great answers that I know are going to be provided. All right, so we've gotten some wonderful answers here, and I want to kind of look at a few and get us rolling. So the first answer that we had that buzzed in, we're going to have that James actually buzzed this question in. For the question, or this answer, excuse me, what is the shape of the Earth? James said a circle. So that's a good job, James. When we think about the different evidence that we do have in scientific understanding is that the Earth would be in a circular form, and that would be the overall shape. Now, Susan here said that the Earth is a sphere, very similar to the circle, but one of the things that Susan wrote under the word sphere, which I think really helps in our understanding, is 3-dimensional circle, okay? So now Susan has expanded that to show that the circle is not just this 2D shape that we're thinking about, but allows us to be within the Earth itself, and thus that 3-dimensional aspect is even a little more specific. So good job, Susan. Next, we have Rashad, and Rashad said flat with 2 question marks. And then mentioned, I've seen some recent videos of researchers explaining how the Earth is flat. That's really interesting, okay? You know, that's kind of been a newish debate in the last few years, is that the possibility, you know, that flat earthers, or as we're called, believing that the Earth is a circle, that possibly the Earth is flat. And so there are a lot of people that have kind of jumped on that and that understanding. We're going to be talking about that. We're going to be addressing that issue because it's very important that we look at and understand really the shape of the Earth to really understand a lot of the processes that happen and that occur. So great answers, and I do appreciate all those answers that were provided for us. So we're going to go ahead and hop on into our lecture this morning. The first thing that I want you to remember is this is our note sheet. This is our note sheet. You can either, this was emailed to you before, it may also be posted in whatever digital form that we may have. And then the third thing, you may either print this at home, or you can simply follow along with whatever device that you're using to complete as we go through our notes. So as we work through our lecture and our notes, these blanks will come up and you'll be able to fill this in. This sheet is going to be very helpful for your studying. It's going to be very, very helpful for your review. And remember, you need to add even more to this. This does not cover every single thing that we're going to look at, but it does give the high points that are very good for us to think about. All right, let's go ahead and get started. Okay, so what we are going to do today, again, we had our Padlet introduction. Now we're going to begin and do a few minutes of our lecture. And then we're going to work to our Nucella article, in which we'll be doing some reading to help our understanding of this scientific revolution that's happening at this point in history. And so the standard that we will be addressing, the state standard, says this: obtain and evaluate information about Copernicus, Galileo, Kepler, Newton, and Einstein to communicate how their findings challenge conventional thinking and allow for academic advancements in space exploration. So that's going to be our focus today. And I'm ready for us to jump in. And we're going to start with the one who was the earliest, which was Nicholas Copernicus. All right. So Nicholas Copernicus. Overall, what I want you to think about when you think about Copernicus, I want you to think helioseismology. Helioseismology. And what helioseismology means is sun-centered seismology, okay? A sun-centered seismology. Copernicus, I don't quite agree with the statement that he was the first one. There were some others who had already articulated. Descartes of Samos is actually one, that the earth was a circle, but he was the one to truly first prove that the earth was a circle using physics, mathematics, and some other surveys. So he was the baseline. He got us started, and from him, we got Galileo, Kepler, Descartes, and Newton all really developed from his findings and his understanding. So sun-centered helioseismology. So as we move forward, Copernicus was born in 1473 in Torun, Poland. His original name was Michał Kopernik, and he was the son of Nicholas Kopernik and Barbara, Watson-Road. And so when you think about some of these European changes that are happening, we have some colonialism that was occurring. Remember, about a few decades after this, we're going to start exploration that's going to go into the Western Hemisphere. And so, we're familiar with some of the contributions historically, of people such as Ponce de Leon, Christopher Columbus, and things of that sort. And so we're kind of around that timeline. And so we know that science is never linear. It is a web. It is a root system. It connects to all other aspects of education as well, such as history, math, and other things. Now, his father died when he was 10, which caused him to be cared for by his uncle, Lucas Watson-Road, who worked inside of the church. And so there was a religious kind of component that was present in Copernicus. And we see that his work in the church is going to continue for a lot of his life. We see that he would go to the cathedral school in Wałczo. And in 1491, the University of Krakow is where he would then attend. And then he's also working while he's doing this. So he has a career in the church. His Watson-Road, his uncle, wants him to further that career and get going. So for the particular recording, we would pause here, or we would expand just a little bit. And now what I would do as we would finish this lecture, we're going to exit out, and we're going to assume that this lecture has been completed or to a stopping point. All right, students, so what we're going to do now, as we've looked at a good bit of our background on Nicholas Copernicus, now what we're going to do, this is the article that's present. It's described as Science, Theology, and the Copernican Revolution. This is going to expound on some of the things that we had discussed. So I think it's going to be a wonderful article for you. I'm going to give you about 5 to 10 minutes to go and begin the reading of this article. After that, you have a discussion question and an assessment that we're going to complete. So in this discussion question, it says this: what you'll be doing, as we always have to expand our reading skills, our writing skills, and our comprehension. I'm going to have you summarize this particular article, and I'll even be giving you feedback on this particular summary assessment in order to help you know some points that you're doing very well in your writing and some other points in which you can grow. And so our prompt is: write a summary of the Newsella article. In the summary, you need to directly quote the article at least 2 times. Your summary must be 5 to 6 sentences. That is uploaded for you. You can go ahead and begin. So that's going to conclude this portion of the lecture. Now I'm going to stop sharing. And so that would be the overall that we would complete within the lecture period. And so the other things that were mentioned for us to discuss there within this particular lesson is how to address differentiated learners, which I think is so important and so essential to make sure that these students are getting everything that is needed and understanding things as needed. For the students with an IEP, those adjustments may be made to where instead of 5 or 6 sentences, they may do 3 or 4, or they may have a peer helper during that time. It just depends on what's best for that particular IEP student. For the students that are then struggling, which there are a few that are not quite up to proficiency, one of the things that's going to be very important is engaging those students, whether within the time in which they are writing or also afterwards, giving them feedback to address these concerns that have been present to where they're not up to proficiency. If it is simply a comprehension of material, that's going to help. If it is kind of expressing those in this particular assessment, expressing their writing skills, this is going to be a very good help for me to then begin to gauge where I can go to help improve their proficiency. Because reading, writing, and then those listening aspects that were present in the notes, it goes ahead and gives them a background for the text and for what has been mentioned. And so to know that they have met the outcomes, that they have met the good summary in those quotations that are present, they will get that positive reinforcement and positive feedback in that particular chat. What I would do, I would go in and put that note for each student, which will be very helpful for them to know what it would look like. The success for the outcome of this particular lesson, students are able to summarize the overall contribution of Nicholas Copernicus and show the influence that was present from the information in the article of helioseismology as opposed to geoseismology, which is going to be a big difference. Next, the teaching strategies and practice that will be used to help this. One of the big Marzano elements that I think is going to be very important with this is going to be chunking. And especially for my target audience and my IEP goals and skills, if I'm able to break down those elements just a little bit more, as we mentioned, the big word that I wanted them to get from the lecture today, helioseismology. And the next lecture is going to be Commentariolus and De Rev. Those are the 2 books that Copernicus wrote for us to understand that he and how he proved and articulated helioseismology. So when they get those key words and those key definitions, they can start to build on those other elements as well that are going to be very helpful. And so when we think about that gradual release and the responsibility that's going to be present on the students, one of the things that is going to be frequent and engaging is frequent assessments throughout the lesson. Whether those be oral assessments, it might be a little question that I would put inside of the Zoom chat for them to answer, to show their engagement, to show their comprehension. Those assessments are going to be very important for me to understand, for me to see not only who is participating, but who is then applying the information that is put into place. Different materials that we mentioned, Padlet is a great material, Newsella is a great format. Those are some of the digital formats that I think are very helpful in a virtual lesson. A Google applications, whether it be Google Docs, Google Classroom, again, are wonderful elements that are able to use so that you can have a live feed of those answers being turned in. I can provide feedback and I can provide a grade for them. And so there are plenty of other assistive technology. Later on in this lesson, one of the technology portions that are used are going to be limiting the number of modifiers for IEP students or IEP students or maybe into RTI students. And so those modifiers can then create the equity that's needed for those particular students. And so I do believe that that is addressed all those things, and that's a snippet of the lesson. I do hope that you enjoyed.